In this equation, we have the proper format, which is first and foremost. It needs to be in the format of ax squared plus bx plus c equals 0. So that's what we have here, so that's good news. And we just want to identify the a, b, and c values, because once we have those, we know exactly what's going into our formula. So the a value is 2, the b value is 5, and the c value is negative 3. All right. So what we want to do is plug that information into that quadratic formula. All right. So everywhere there's an a, we're going to replace it with a 2. Everywhere there's a b, we're going to replace it with a 5. And everywhere there's a c, we're going to replace it with a negative 3. All right. So x would be equal to, and what I'm going to do is I'm just going to rewrite the formula with open parentheses everywhere there's a letter. It's kind of like a weird intermediate step that you might not think has any value whatsoever. But what I've come to learn over the years is that when people don't do this, they tend to make an order of operations mistake. And so it's just a good habit to get into. All right. So let me get my highlighter out. Oh, that is not my highlighter. That's my highlighter. So and I guess red. So negative in parentheses 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3 over 2. Just again replacing all my a's with the a value, which is 2, all my b's with the b value, which is 5, and my c, there's only one of them in the formula, with the c value, which is negative 3. So that's the easy part. It's just plug in values in. Now I have to crunch those numbers. So negative, whether there's parentheses or not, negative 5 is just negative 5, so I could rewrite that. Plus or minus, the real work is going to come from figuring out what's under the radical. 2 times 2 is 4, so that's where your calculator is going to come into play. You don't have to do it in the calculator, you can do it by hand, but most of the time people find themselves using the calculator, so let me just walk you through that. So if you use this parentheses method that I was just talking about, the idea of replacing all the letters with an open set of parentheses, then what you can do is type directly into the calculator whatever you have under your radical. Do not include the radical, because if you do that and it's not a radical that simplifies, then you're going to get an ugly decimal. And if your answer needs to be in simplest radical form, that's going to be a problem. So all we do is we just take whatever is underneath the radical and type it in our calculators exactly the way we see it in the formula. And this one ends up being a clean answer of 49. All right. So that's great news, because with a 49, that's telling me that I'm dealing with a perfect square. And when I have a perfect square, it's going to clean up nicely. I mean, I don't know too many folks that need a calculator to figure out that the square root of 49 is 7. But just in case, you could put it in. One of the biggest pitfalls when it comes to completing the square is forgetting to put the plus or minus in for when you take the square root. This is not an issue, because the plus or minus is already built into the formula. All right. Later on in the unit, we'll learn why that is, but for now, we're just going to work with the formula as is. So negative 5 plus or minus 7 over 4, and then we just got to figure out what that's equivalent to in terms of whole numbers or integers or rational numbers, because we can. there's no radical in there. So you could actually take that next step. So we have -5 minus 7, which is -12, divided by 4 is -3. Or we have -5 plus 7, which is 2, divided by 4, 1/2. All right. So when you get clean numbers like that, it means that you could have solved by factoring. You could have solved by completing the square. All right, but we're learning how to use quadratic formulas, so that's why we're doing it this way. All right. The second problem, in terms of the setup, it's no different. All right, so we identify the A, B, and C values. You got to make sure it's in the proper form first. All right, so I identify the A, B, and C values just by taking note of the coefficients. So I have the A value is equal to 1, the B value is equal to 3, and the C value is equal to -5. I'm going to rewrite my quadratic formula, again with parentheses everywhere that we had a letter. So B squared minus 4 times A times C. I'm just going to move it over a little bit. All over 2A. And again, I'll just do a quick color code. So negative, plugging in the 3, plus or minus the square root of 3 squared minus 4 times A times C, all over 2A. All right. When we clean it up, we're still going to have that -3. We're still going to have that product of 2 and 1 on the bottom. The hope is that we can make that radicand a little neater. All right. So just type it in the way you see it, because if you use the parenthesis technique, it's not going to be an issue. You're going to get the appropriate answer without having to worry about order of operations. So you get a 29, so that 29 goes under the radical. And then you do have to ask yourself, is this something that can be simplified? All right, so you'd want to think whether or not a perfect square factor can divide evenly into the 29. If the answer is no, then you're done, which is great news. It makes this kind of problem the sort of problem where you start to look forward to rather than dread. Because actually, if you do a quick comparison in terms of the amount of work that you had to do between numbers 1 and 2, 1 had the nice clean answer, but 2 had less steps. Once you got that radicand, you were done, right? So you start to kind of look forward to the radical answers rather than the rational ones, all right? So in this case, there is no perfect square value other than 1 that'll divide evenly into 29. So because of that, we just call it quits in this step. That's the end of it.
Could I just go back?
Yeah. All right. So let's just do one more. Something with a fraction in it. Do number 3.
Well, we have to memorize that I B plus 1.
Yes, sir, you will. All right. So we have our A, B, and C values.
I mean,
All right, so x is equal to negative, whatever the b value is, plus or minus the square root of b squared minus 4 times a times c. Just scooch it over a little. All over 2 times whatever the a value is. All right, so again, it's really just a matter of knowing what goes where, and you'll be in good shape. So the b value is going to go here and here. The a value is going to go here and here. And the c value is only represented once. So that negative x, there's an understood coefficient of 1 there. So it's really a negative 1, even though the 1's not written. So it's really saying negative 1. So negative 1, it's going to be 1, yeah. Minus 4 times 1/2 times negative 4, as soon as my pen decides it wants to work. Over 2 times 1/2. So x is going to be equal to, we got the 1, we have the plus or minus. The whole thing's going to be over 1 because 2 times 1/2 is equal to 1. So that's telling me I don't really have to even write the denominator because anything over 1 is itself. So I'm just going to ditch that. So my only concern now is figuring out what's going in the radical. So that's where my calculator comes into play. Negative 1 squared minus 4 times 1/2 times negative 4. We get a nice clean 9. And we know that the square root of 9 is normally plus or minus 3, but because the plus or minus is built into the formula, we could just say 3. And then we can just figure out our answer by saying what is 1 minus 3? Negative 2. And 1 plus 3? 4. All right, and so we have our solution. All right. So at least in the beginning, you'll be referring back to that formula to get your